These are the Statistics Lesson 4 notes, relations between shape, outlier, center, and spread of data. To review finding outliers, we're going to follow the 3 steps that you see here. And the first thing we need to find is the IQR, which is Q3 minus Q1. In the past, when we've worked with a data set, our numbers are in numerical order. We kind of work our way from outside to inside to find the median. I like drawing a line where the median actually is, which would be right here at 26. This splits your numbers into 2 kind of sets here. We've got a smaller group of 5 numbers down here and a larger group of 5 numbers here. The middle of this smaller group of 5 numbers is right here at 20. That's where our Q1 is going to be located at. And the middle of this bigger 5 numbers right here is located at this 30 that I'm drawing my line through right here. So this is where Q1 is located at. This is our median right here, which we don't really need right now. And this is Q3. So when we list the 5 number summary for the data, we're going to start with our minimum number. That's this number right there. That's the 2. Q1, the first quartile, which is 20. Our median in the middle there, which was at 26. Q3, which is right here at 30. And our maximum, which was here at 49. You don't have to label them Q1, minimum, maximum. Just list them in this order. To find outliers, we're going to use this 1.5 times the IQR formula, which is addressed up here. The first thing we need to do is calculate our IQR, which is found by taking Q3 minus Q1. When you take Q3 minus Q1 in this problem, we're going to subtract 30 minus 20. And when you do that, you get 10. That's our IQR. In our second step, we're going to take Q1 minus 1.5 times the IQR. So we're going to take Q1, which is 20, minus 1.5 times the IQR. The IQR was 10. 1.5 times 10 is 15, so we're going to take 20 minus 15, and that is equal to 5. On the other end, for step 3, we're going to take Q3 plus 1.5 times the IQR. So we're going to take Q3, which was 30, plus 1.5 times the IQR, which again was 10. 1.5 times 10 is 15. 30 plus 15 is 45. Outliers are any number that is smaller than 5 and bigger than 45. In our list of data, we have a couple of numbers that are smaller than 5, 2 and 4. And we have one number that's bigger than 45, which is 49. So our outliers in this problem are 2, 4, and 49. When we draw our box plot to display the 5 number summary, we always do a scale first. Our numbers kind of range from 2 to 49. 0 is pretty close to 2. 50 is pretty close to 49. So if we could kind of span from 0 to 50, that might be nice. I thought about doing 10, 20, 30, 40, 50, but I think we could go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That would spread out our data a little bit better. I kind of like using as much of the scale as possible when we draw our box and whisker plots. So the 5 number summary are going to be these vertical lines that we're going to draw on our box plot. We're going to draw a vertical line at about 2, should be about there. Right at 20, there's our Q1. Our median at 26, a little bit past 25. 30, which is where our Q3 is located at. And 49, which is where our maximum is at. We'll draw our box right here. That supports our Q1 and Q3 with the median in the middle. And then we have these whiskers that go out to our maximum and our minimum. That's your box plot. To create a modified box plot, which we're going to do next, utilizes a lot of the same information that we just had. However, you might notice that these whiskers extend way to the outside. It kind of makes it look like we have a lot of data between 30 and 50, where in reality, the only points we have between 30 and 50 are really the 32 and the 49. So this whisker kind of makes it look like we have more data than we really do. So box plots that display outliers often have long whiskers, and it gives the reader the false impression that data is evenly spread out evenly along the whisker, when in reality a single outlier may be the reason for the long whisker. On a modified box plot, the whiskers extend to the smallest and largest values in the data set that are not outliers. Outliers are plotted as individual points. So we're going to plot the same graph that we had last time. However, what we're going to do is we're going to plot the outliers as individual points. So I'm going to use the same scale that we had before, counting by 5s. I'm only going to label every 10 units because it starts to get a little messy on the graph if we start putting like 5, 15, and it just kind of makes the graph look a little cleaner. I'm going to plot the outliers, 2, 4, and 49 as single points. So I'm going to put a point here at 2, a point here at 4, and a point here at 49. The box is going to be in the same place as before, so the 20, 26, and 30 aren't going to change. I'm still going to have a vertical line at 20, 26, and 30. So on a modified box plot, the box stays the same. However, the whiskers extend to the last points that are not outliers. So in our data set up here, 2 and 4 are outliers. 20 is the first point that's not an outlier on the small side. So the whiskers is only going to extend out to 20. However, that's where the box ends. So here we're not even going to put a stub of a whisker. The whisker would extend out if there were points that were below 20. But there aren't any, so we just have kind of a box here. It'll make a little more sense on the other side. Our biggest point here that's not an outlier is 32, so we will have a whisker that extends out to 32 in this direction. Put that little line right there. So on the small side, there are no points below the first quartile that aren't outliers. I'm sorry, there are no points beyond here that we could extend a whisker to. I mean, the smallest value we have is 20, so we just kind of end it here. On the bigger side, we can extend a whisker out to 32. This is a modified box plot, and it gives you a better sense of the fact that our data is primarily in this little region right here, and we have a few outliers on the other sides. One last thing about graphs. We're going to be looking at shapes of graphs today. Shapes of graphs can be explained by looking at the locations of the tails of the graphs. We have 3 graphs that are listed here. This graph is called a left skewed graph, and you might notice that the tallest part of the graph is up here on the right side. The tail is on the left side, so we call this a left skewed graph because the skewness follows the direction of the tail. If there's a long tail on the left, we call it left skewed. If there's a long tail on the right, we call it right skewed. Now, these are graphs of kind of like a histogram type shape here. On the graphs at the bottom, these are our box and whisker plots, and you'll notice on a left skewed graph that the distance from the median to the minimum is longer. There's kind of a longer distance here. Sometimes you'll see a longer whisker on the left side, but in general, it's a longer region from the median to the minimum. That kind of gives you the idea that this is left skewed. There's a longer distance this way than there is this way, so it's left skewed. If it's about even on both sides, we say that the graph is symmetric. And if you notice that from the median to like the third quartile, or the median to the maximum, is a lot longer than it is on the right side than the left side, that indicates a long right tail, and the graph would be right skewed.